Students, I am really happy to see you here. In this class, we are going to solve a very important problem here, and this is what the payoff matrix given to us. N is one player, M is another player. He is in the winning mode, he is in the losing mode. He have two strategies, x1, x2, and he has four strategies, y1, y2, y3, y4. Okay. We have to solve this particular game by what is called graphical method. Okay, graphical method. We have to solve this. First, our aim is that to change the given matrix. Actually, this is 4 by 2 matrix into 2 by 2 matrix. Okay, then only we can solve that particular problem. That's what it is in our syllabus. So how to reduce this? Actually, this is what matrix. Four rows are there. 4 by 2 types. Am I correct? But we have to reduce that into 2 by 2. Then only we can find out the minimax, max min, whether they are equal or not, and everything. Okay. Right. So how it is that possible? The one way is that dominance rule, okay, but it is not given here. Graphical method, that's what we have to look at. So this 4 by 2 matrix we have to change into 2 by 2 matrix. Okay, for that we have to use the graphical method. Okay, so now let us see how I am drawing the graph very carefully, and then we can reduce that 4 by 2 into 2 by 2. Now x1, I am drawing a one vertical line here. This is what I say x1. Now I am drawing the line very near here because we have to solve this problem. It will take its own space. So I am drawing an x1 axis here and x2 here. The strategies of the second player I am taking as two parallel lines 1 unit away, suppose. Now on this, okay, on this I am measuring as 0. This is 0 point. This is 1. This is 2. This is 2. This is 3. Like that I am measuring on this. Okay, this is 4. Like that. This side we know that minus will come there. Am I correct? So minus 1 is this, then minus 2 is here, then minus 3 will be here, and minus 4 will be here. Okay, that's what you have to understand. Similarly, in this vertical line also, I am measuring this is 0, and this is 1, this is 2, and this is 3. This is 4. Last one 5 should come there because we have 5 point also on the graph. This side minus 1. This is minus 2. This minus 3. I think that's enough for us. Okay. Now look at this particular matrices. When x1 takes 1, x2 takes 2. So when x1 takes 1, okay, here 1, I can change the color. When x1 takes 1, x2 takes 2. So x1 on x1 vertical line you are taking 1 point, and then x2 will get 2, that is here. Right. So I am drawing a line like that. And afterwards x1 takes minus 1, x2 takes 3. x1 takes minus 1, x2 takes 3. So minus 1, 3. Minus 1 is here. Minus 1 is here. Okay. And here it is 3. So I'm joining these two line points. Now third point is when x1 takes 4, x2 takes minus 2. x1 takes 4, 4 is here, x2 takes minus 2. So on this line minus 2 is where? Here. So I can join these two lines. Okay, these 2 points I'm joining. The last point, when x1 takes 5, x2 takes 1. So 5, x1 takes the value 5 point. X2 takes minus 1. Minus 1, why is that? Here is a minus 1. Now join these two. Okay, very interesting. Now, it's very important to see that this is the area of maximum loss. This is the intersection of all the graphs. Okay, that's what this area, intersection of outside of that is called maximum loss. All these are maximum loss. Okay, you must know that all these areas are maximum loss. Okay, maximum loss. Maximum loss. So among the maximum loss area, so we are drawing a upside graph for all. The intersecting area is this. Okay. So among this, which would be the minimum point? Because the aim of the player M is to minimize his maximum loss. Am I correct? Maximum loss. That's what his aim. So here, maximum, all these are maximum. Okay, all these areas are maximum. Among them, which is the minimum? I think the minimum point may be this. Look at that. Am I correct? If you take this particular intersecting area, the minimum point would be this one. Am I correct? And of course, this is what, which are the two lines here. So it is better that y1, 1 to 2 is, this is y1. Am I correct? Minus 1, 3. Minus 1 is here, 3 is there. So this is actually y2. And x1 is 4. X2 is minus 2. 4 minus 2 is there. 4 minus 2. This is y3. And then 5 minus 1. 5 is here. Minus 1 is here. This is what? Y4. So actually, what we understand is that this is the intersection of this line and this line. So this line corresponds y1 and this line corresponds y4. Am I correct? So only the two strategies of n is a prime to make this criteria. Am I correct? I mean this one y1, that is what y1, and y4. Y4 is what? This one, y4. Am I correct? So only these two strategies of the player n taking place in this particular play, in this particular criteria. Am I correct? Therefore, what can I say is that, so this particular player n need not to play y2, y3. Okay, so he need to play only two strategies, y2 and y4. Okay, this is 1, this is 2, and this is 5, this is minus 1. Okay, but the player M has to play both the strategies, x2 and this is x1 and x2. Okay, this is x1 and x2. x1 and x2. Now look at that. So what we see here is that this matrix of 4 by 2 is changed into 2 by 2 matrix like this. Okay. So this is the way that we can change any matrix, but condition is that either this player or this player should have only one strategy. Then we can use this particular graphical method. If M is having only two strategies, then we have to take the upside area, because that will be the loss to B. Suppose N have only two particular strategies, then we have to take the downward area, because that will give you the minimum gain to the player N. So down area we have to take. Only that you have to remember. Okay, so like this we can make the given 4 by 2 matrix into 2 by 2 matrix. Okay, so afterwards we can solve by the method that we discussed before. Okay, we can get a pure match, or we can get a pure game, or we can get a mixed game. We can do from this particular graph. Okay, so that's a way we can make the graphical method to reduce the given matrix into 2 by 2 matrix. Okay, so with that we have to come to the end of this particular session. Thank you.